Hi, and also welcome to a tutorial from my side. My name is Stefan Liebald and I want to guide you through the practical parts of this tutorial. So first of all, what will we do? As you probably already know, we want to build a small game, and you might have already seen the real hardware that could implement such a game. What we will do is we have an emulated device which has the same functionality. You can see it here already, and we will implement the logic behind that game. First of all, this is already the fully functional game now, so let's have a look at what we can do here. So the board is split in two parts. We have a part for the player 1 and a part for player 2, and one LED in the middle. And each player has one button that he can press, which is on your keyboard the key D for the left player and the key J for the right player. And then each player has a symbol that shows like, okay, this is the actual, or is the button pressed or not. LED that turns green if the button is pressed, so currently it's off, and the LED that turns red based on the state of the game. Now let's have a look at how that actually works. So now I'm pressing the button D, and as you can see, hopefully, so if you not see it, you can test it on your own device later, but now the symbol here shows a closed circuit, and we have a green LED lighted up. And if I now go on and press both buttons at the same time, you will notice that the LED at the top will turn blue, which indicates that the game is now running. And the goal is then that the red LED of one player turns on randomly at some point in time. And if that happens, that player has to take his finger off the key as fast as possible. And the same then afterwards for a second player. And then the light of or the LED of the winning player will start blinking to indicate who won. So let's try that once quickly. I press both buttons. The blue LED has turned on. Now the red LED went on, and the left one, I put my fingers off the keyboard, and we can see, hopefully, the left LED is blinking, which tells us, okay, the left one won. So I was faster with my finger on the D. We can also see the results in Firefox afterwards. So first of all, at the bottom, so I already played once before, we can see at the left side the high score. So this is the top 10. First place needed like 581 milliseconds, second place more, and so on. And on the right side, we can see the last player. So in case we play more than 10 times, because it only shows the top 10, we can also see all players. And also in the top, we can see what actually happened inside our system. So which operation on which addresses from which servers went through, which values were set or received, and what was the delay of that operation. Okay, so that is a basic game when it's fully working, but we provide you with a skeleton code, and we will walk through the different steps where you actually have to implement those. So different steps are, first of all, we have a look at how the VSL actually works with the different services, where they connect to each other, when the knowledge agents connect to each other, how they synchronize their data. Then we will update a context model, which basically describes these elements of the smart device. Like the context model will have an element that says, okay, this is a button, and you can read it to get the state of the button, so is it pressed or not. Afterwards, we will update the gateway service that it reacts to changes on operations on the different nodes in the context model, and we will implement the orchestration that basically implements the logic behind the game. So wait until both buttons are pressed, read the time that was needed, set the LED states on and off, all using the VSL as middleware and interacting between the orchestration service and the gateway service, and also reporting the results to a leaderboard service and different kinds of operations to a monitor service. Good. So before we come to that, let's have a quick look at what we provide you with. So when you start let's close that. It won't close. So if we start the virtual machine, what we see is that blank desktop basically, And in the top left, you have everything you need. So I'm a bit too small, but in the top we have Eclipse as a development environment. We have Firefox as web browser to display us the results that we just saw, and also for an IRC client where you can chat with me, because unfortunately, well, I'm not with you, I'm in Germany, but I'm available via IRC, so you can ask me questions there if you get stuck and stuff like that. We have the, sorry. We have a terminal shortcut, so you can either press Ctrl-Alt-Enter to open the terminal or just click here. We have a team viewer, so in case you really get stuck, you can open up the team viewer and use IRC to write me your ID and password, and I can connect to your virtual machine and help you directly. And last but not least, we have here the tutorial files, which is basically all the files that you need for that course or for that tutorial. So the web folder contains the website that we just saw. The code folder contains the skeleton code that is also already imported in Eclipse. We have the certificates folder, which includes all the certificates, which you don't need to worry about because these are already used by default, so you don't have to do anything with that. And in the bin folder, the binary folder, you have different scripts to execute all the different executables. So here the executables like the control service here are already fully implemented and working, so you can use those to play the game. But you will also complete the skeleton code on your own and can maybe also give the game a different twist if you want to.